Welcome to this walkthrough on automating Route 53 DNS updates with Terraform, a hands-free way to update your DNS records when your ALB changes, like during Kubernetes upgrades. In many Kubernetes environments, especially when using the AWS Load Balancer Controller with Traefik, application load balancers, or ALBs, can be deleted and recreated during changes, like cluster upgrades. But when this happens, your Route 53 DNS records still point to the old ALB. This creates downtime and manual overhead. This guide shows you how to fully automate this DNS update process using Terraform, so your domains always stay in sync with your latest ALB. You can find the full source code and shell scripts in the public GitHub repository shown here. This includes Terraform modules, automation scripts, and Kubernetes YAML files. The automation starts with a bash script, apply terraform.sh. It waits for the ALB to become active, retrieves the hosted zone ID, and then either imports an existing DNS record into Terraform state or creates a new one. Here's the wait for ALB active function. It polls AWS to make sure the ALB is active before continuing. This prevents Terraform from applying configurations prematurely. We then call this function with your ALB name. If the ALB doesn't become active in time, the script exits cleanly. Once the ALB is ready, we move to the Terraform directory. Fetch the correct hosted zone ID and check if a DNS record already exists. If it does, Terraform imports it. If not, a new one is created and applied automatically. The Terraform project is organized into a root main.tf and a module directory named root53-alias-for K8ss-LB. This module contains the logic for discovering the ALB and creating or importing the Route 53 DNS record. In main.tatf, we define the AWS and Kubernetes providers and call the module that manages DNS. You'll pass values like your domain name, namespace, and ingress name to the module. Here's where the heavy lifting happens. This module uses AWS tags to find your ALB and dynamically creates a Route 53A record alias. It uses data lookups to fetch the ALB and hosted zone metadata, then provisions the record accordingly. Variables like zone name, record name, and Kubernetes ingress metadata are all declared in variables.tf, making the module reusable for multiple environments or apps. For this automation to work, your ingress resource must include ALB-related annotations. The critical tag here is servicefoundry.org/service-name, which maps to the Kubernetes namespace, and ingress name Terraform relies on this tag to locate your ALB. The process is simple. 1. Apply the ingress YAML file that provisions your ALB. 2. Run the apply terraform.sh script. 3. Terraform will import or create the Route 53 record pointing to the ALB. Now that everything is set up and the ALB is active, we're applying our Terraform configuration. This step may take a minute or two depending on your environment. Behind the scenes, Terraform is checking the current state of Route 53, comparing it to the desired configuration, and determining whether to create a new DNS record or update the existing one. If a DNS record already exists for our domain, Terraform will import it into its state file to ensure safe and repeatable infrastructure changes. If there's no record, it will provision a new A record alias that points directly to the ALB DNS name. This automation eliminates the need for manually copying DNS values from the AWS console into Route 53. It also helps prevent misconfigurations or typos that can easily cause downtime. Once this apply step completes, our domain will be automatically mapped to the newly provisioned ALB, and the site will be accessible with HTTPS using the ACM certificate we've already issued. So, just hang tight, we'll verify the DNS changes shortly and make sure everything is wired up correctly. After the script completes, verify your DNS with a simple dig command. It should return the CNAME or IP of your newly created ALB. By using Terraform for Route 53 updates, you reduce downtime, eliminate manual DNS edits, and ensure your domain always routes traffic to the correct ALB. This is especially helpful for production environments where reliability matters most. For more details, check out the AWS Load Balancer Controller docs, Terraform provider documentation, and AWS Route 53 developer guide, all linked here. Thanks for watching. If you found this helpful, please like and subscribe. See you in the next video.